Okay, so let's review some of the basics of the 4 homeostatic mechanisms that are all negative feedback that we've covered so far. So for temperature, the set point's 98.6 degrees Fahrenheit. Thermoreceptors are the types of receptors that sense the change. If your temperature rises too high, you will sweat. And remember, it's not just sweating that's going to cool you off. Actually, it's not sweating at all that's going to cool you off. It is when the sweat evaporates into gas. Going from liquid to a gas, you add heat from the human body. And when you add heat from the human body to force that phase change from a liquid to a gas, then you will drop your body temperature. As well as we want to shunt blood to the skin, so we are going to vasodilate your peripheral blood vessels. So by shunting blood to the skin, that brings more blood to the surface, so you can lose heat via convection, and by, ooh, that's cool, conduction, okay? And therefore, your skin will turn red if you have light-colored skin. Conversely, if your body temperature is too low, you're going to shiver, which is the involuntary contraction and relaxations of skeletal muscles, and that will drive your body temperature up. If you don't believe me, grab your arms like this and start to shiver, and you can actually feel yourself warm up. In addition, we will also shunt blood to the core, so you're going to peripherally vasoconstrict and shunt blood to the core to conserve heat, and that will turn people pale if you're light-skinned. Glucose, 70 to 110 milligrams per deciliter. They are sensed. Their glucose levels are sensed by chemoreceptors. If your glucose levels are too high, you're going to need insulin to bring the glucose into the cells and lower your glucose levels. Conversely, when your serum glucose levels are too low, you're going to secrete glucagon, which will then stimulate cells in your liver and your skeletal muscles to hydrolyze glycogen into glucose and release the glucose into the bloodstream, thereby raising your blood sugar. Calcium, 9 to 10.5 milligrams per deciliter. Chemoreceptors, because it's blood chemistry, sense this, and when your calcium levels are high, you're going to produce calcitonin, which will then prompt the storage of calcium in your skeletal system. Conversely, when you're low in calcium, you're going to produce PTH, will then prompt bone cells, specific bone cells, to basically self-destruct. And well, not really, but they're gonna cause bone cells to release acids, which will dissolve some of the calcium and release the calcium into the bloodstream. Lastly, blood pressure, 120/80. The receptors are baroreceptors because they sense pressure. They're actually really cool. They are actually stretch receptors. So when your blood pressure is low, the cells that surround those baroreceptors that surround the blood vessels are relaxed. When your blood pressure is high, those cells get stretched out. So that's how baroreceptors work. When your blood pressure is too low, you want to increase the heart rate and shunt blood to the core. You are going to increase heart rate by stimulating beta-1 receptors, and you're going to shunt blood to the core by stimulating alpha receptors. And when you do that, we need to get blood to the brain. And when you do that, when you shunt blood to the core, peripherally vasoconstrict, you're increasing systemic vascular resistance and turning pale. When your blood pressure is too high, we're going to do the opposite. We're going to lower the heart rate, and you're going to shunt blood to the skin. And you're going to shunt blood to the skin by reducing systemic vascular resistance by vasodilating and spreading the blood out to the skin.